Hello, good morning everyone. Today we are going to cover the diphenylacetylene session from your CHEM 2 course. And this is the reaction from steel benzene dibromide. Here is the reaction scheme, and this is exactly where we are, which corresponds to the chapter 28 of your book. The reaction we will be carrying out today is starting by potassium hydroxide. The hydroxide is going to perform an elimination reaction in the steel beam bromine molecule, removing one of the protons and ejecting one of the bromons from the molecule. The ejected bromine is going to be captured by the potassium contraion, creating a potassium bromine as a salt, right? And we are going to make a steel beam, double bond steel beam intermediate, which is an intermediate of the reaction of today's lab. This compound is further then attacked by the triethylene glycol anion. It is because the potassium hydroxide is going to remove one proton from the triethylene glycol, making the alkoxide of this. This base is strong enough and is so abundant because it is the solvent of the reaction, and that is going to be able to produce or generate the second elimination of bromine from the steel beam to create the triple bond in this steel beam bond molecule. Taking the second proton and ejecting the second bromine and making our product molecule. So the comparison of relative expected proton acidities is the following. The bromine on the same carbon inductively stabilizes the formation of an ion. The anion also stabilizes by its resonance delocalization into benzene ring, as you can see here. That's why it's much more acidic. Remember, this is during the first attack. We have this resonance structure that is very stable and is going to prevent or protect the second proton from being attacked in the first elimination. So the much less acidic, the electron withdrawing bromine only on neighboring carbon, less stabilizing of ion. Also, the ion existing in sp2 bonding orbitals not delocalized as easily into benzene rings. Anticipated resonance delocalization is less in this case, right? Therefore, you need a stronger base to remove this proton. This happened, as I already said, with the reaction, because of the reaction of potassium hydroxide with the triethylene glycol, producing the triethylene glycol alkoxide that you can see over here, the reaction alkoxide. This is a very strong, strongest base, since potassium hydroxide may not be strong enough for the second step. As we saw before, we need a stronger base for the second step. This is the second elimination mechanism. It's basically another elimination mechanism in which this base is going to remove this proton and it's going to eject, as a consequence, this bromine, and as a product we're gonna get our product of this reaction, our diphenylacetylene. This second step is slower, so it may require more heating. Here is the procedure for our session. So basically, in a 500 ml from bottom milliliter from bottom flask, insert 2 grams of tilbene dibromide, 1 gram of potassium hydroxide. In here you have to make sure that if the potassium hydroxide is sticky with moisture, then you have it is okay to have a small excess of over 1 gram, but do not weigh less than 1 gram. Also, you need to add 8 milligrams of ethylene glycol. You have to heat the mixture for 5 minutes in the range of 160 and to 170 degrees Celsius range. Then you have to see the knot of upcoming slice. Then you have to cool the mixtures to room temperature. Add 40 milliliters of water to dissolve the potassium bromide. Then in this case you have to make sure that the reaction is cool before doing this, of course, before adding the water. Collect the product via vacuum filtration, and you don't need to recrystallize it. Then you have to weigh the dry product and determine the melting point, and store the product in a small beaker in cabinet specified by your TA. The instruction in case of the heating time recommend heating for 5 minutes at the before mentioned range temperature. It is not uncommon for this reaction to require a longer heating period than 5 minutes, but it is recommended to heat for 10 to 5 minutes, but not let the temperature go above around 185 degrees Celsius. That's why heating too much can produce inflammation of the TEG. Then, and this come out the question that you need to look into before, because you need to know the boiling point of the TEG. You have to look for it. That's why the temperature control is so important, right? As we mentioned, the temperature should be maintained in this range, do not exceed 185 degrees, and as we mentioned before, the boiling point of TEG is high, and a reflux, which means boiling, at the boiling point of TEG will be dangerous, as you may know, and might decompose your product. So we need to control the temperature to avoid the reflux. Then, to best control the temperature, clamp the flask and raise and lower it into the heating mantle, right? One can also raise or lower the heating well, but only if the flask is clamped. This is very important handling skills or manipulation to manipulate the reaction and to control the reaction in order to get a high yield in the product. Again, to specify, you need to add water after the solution is cold, right? This is because we have to make sure that water do not vaporize dangerously, right? If you add water into a very hot surface on a very hot substance, what may happen is that water instantly evaporates and make vapors too quickly that can explode or can also damage you, damage your skin, or cause any other damage. So we have to make sure that water is added when the solution is cold enough. Hazards. In this case, we need to know that potassium hydroxide is a strong base and can cause serious skin and eye injuries. Solid potassium hydroxide is deliquescent and will rapidly absorb moisture from the air. This is very important, this parenthesis, which say that the process by which a solid absorbs moisture from the air to form a solution is called deliquescence. This is a very important process. Deliquescence is when the solid absorbs moisture, and the opposite example will be efflorescence, right? So then you have to wait quickly, as the way will change with the time. Will change with the time as moisture is being absorbed, right? Then you have to clean all the surfaces exposed to solid potassium hydroxide, as the residue will absorb moisture and produce hazardous spots and location where you leave the solid. Also, the reaction mixture produces a stronger base by reaction with Tg, which is very hazardous. This reaction has to be heated to a high temperature. That's why you need hot glassware, you need hot protection, right? Because hot glassware can produce serious thermal burns. The hot reaction mixture is much more hazardous to skin than ice. Then that's why the room temperature mixture is still highly hazardous, because some potassium hydroxide remain after the reaction and will produce serious chemical burns. That's why you should use great care. To avoid splitting the hot reaction mixture on you, to avoid overheating, absolute maximum temperature is 185 Celsius. Never look directly to the mouth of the flask. Keep the hot sash down when heating, and as always, you need to make sure that you are waiting the safety goggles and the lab coat and all your protection medias. This is an error that you have to note in your textbook. 2 grams of steel beam dichromate is not 0.0006 mol. Here you have 3 zeros after the point, and it is 2 zeros after the point. You can verify this by calculation, right? The correct number of moles is 0.006 moles of steel beam per 2 grams of steel beam. In the case of the spectroscopy, you must need to obtain the IR spectrum. Of course, you need to use the minimal sample possible, and it may not be possible to recover it. Then you have to obtain the proton NMR and recover your sample by putting the solution onto a wash glass and allowing the chloroform to evaporate. And that's it. Again, as I always tell you, if you have any doubt regarding the procedure, the experiment, the mechanism, or anything related to the lab, you can contact me, you can send me an email, and we can arrange a virtual meeting if needed, or I can answer your questions via email if it is not needed to arrange a meeting. So I hope you all have a great week, and let me know in case of needed. See you. Bye bye.